Hello, this video is on adding and subtracting fractions and mixed numbers with unlike denominators. The first two fractions that I'm going to add are 3/4 and 1/3. Whenever I'm adding fractions or subtracting fractions, I prefer to write the problems vertically. This will allow me enough space to get the equivalent fractions once I find the common multiple, which becomes the common denominator. So the first thing I start out doing is listing the multiples of my two denominators. In this case, it's going to be 3 and 4. So the multiples of 3 are 3, 6, 9, 12. Now, the list of multiples for any number goes on infinitely. But I'm going to stop at 12 because I know that 12 is the fourth multiple of 3. Okay, so now I'm going to list the multiples of 4, which are 4, 8, and 12. Now again, the multiples of any number go on infinitely, but I already noticed that I have a common multiple, and that is 12. 12 indeed is going to be our least common multiple. So I'm going to rewrite the fractions that I started with so that they have a denominator of 12. Now, the goal here is to have an equivalent fraction, a set of equivalent fractions. So I need to figure out what I multiply 4 by to get 12. So 4 times 3 is 12. So 3 times 3 is 9. Now I have to multiply the numerator and the denominator by the same number in order for these two fractions to be equivalent. Now I have to look at 1/3. How do I go from 3 to 4? And that's, or I'm sorry, 3 from 12, and that's by multiplying the 3 by 4. So I have to also multiply the 1 by 4 as well. Again, you have to multiply the numerator and the denominator by the same number in order for the two fractions to be equivalent. So 4 times 1 is 4. Now I'm just going to simply add the two fractions together, but I do not add the denominators. I only add the numerator. So I'm going to end up with 13 twelfths when I add 9 twelfths and 4 twelfths. Right? A lot of the time you'll be asked to turn your improper fractions into mixed numbers. Now that's a lesson in itself, but as a quick refresher, in order to turn an improper fraction into a mixed number, you pretty much turn that fraction into a division problem. So we're going to have 13 divided by 12. 12 goes into 13 once. So 13 minus 12 is 1. So we get a remainder of 1. Now, the parts of this division problem, you use them to write your mixed number. So there is one group of 12 in 13. So my whole number is going to be 1. Then I'll have 1 left over out of 12. So I'm going to write that as 1 over 12. Okay, so in order to turn an improper fraction into a mixed number, you must use division. Your quotient becomes your whole number, your remainder becomes your numerator, and your divisor is your denominator. Now you'll notice that the denominator in the mixed number matches the denominator in the improper fraction. The only time this may change is if you have to end up simplifying, and in this case we don't have to simplify because 1 and 12 only have a common factor of 1. We're going to switch gears here and tackle a subtracting fractions problem. In this case, we're going to have 7/8 minus 1/3. Remember, the first thing is I recommend that you set your problems up vertically. Okay? Now I'm going to list the multiples of both 3 and 8. I'm going to start with 8 because if we list out just the first 3 multiples of 8, we really save ourselves some time, and we could avoid listing out the first 8 multiples of 3 because 3 is not a factor of 8. So we won't suspect that 3 is a a factor of 8 and 16, um, and it is indeed a factor of 24 because 8 times 3 itself is 24. I'm just going to list out the multiples of 3 here, just so you see that 24 is the only multiple those two numbers have in common. Or the only, I'm sorry, 24 is the least common multiple. Now they do have others in common. So our LCM is going to be 24. So that means our new denominator is 24. Now, we need to consider how do we go from 8 to 24 and from 3 to 24. So up here, 8 times 3 is 24. So what I do to the denominator, I must also do to the numerator. So 7 times 3. And there, I get 21. Then down here, we know 3 times 8 is 24. So again, what I do to the denominator, I must do to the numerator. So 1 times 8 equals 8. Now I can just subtract. 21 minus 8 equals 13. 24ths. Now, 13 and 24 only share 1 is a common factor. So therefore, our answer, 13 24ths, is in simplest form. And let's take a look at adding mixed numbers. Adding mixed numbers is very, very similar to adding fractions. The only thing you have to consider here is that your mixed numbers have a whole number, so therefore you just have to take that into consideration when adding. So I'm going to follow the same steps here, listing out the multiples of my two denominators. We're going to start with 7, 14, 21, 28, 35, 42. I'm going to stop at 42 because that's the sixth multiple of 7. List out the multiples of 6, 12, 18, 24, 30, 36, and 42. So the LCM of 7 and 6 is 42. So my new denominator is going to be 42 for both of these mixed numbers. Now, to take into consideration, how do I go from 6 to 42? That's by multiplying 6 by 7. So what I do to my denominator, I must also do to my numerator. So 1 times 7 is 7. Down here at the bottom, 7 times 6 is 42. So I have to do 5 times 6, and I get 30. Now I'm just simply going to add those numerators, 37 and 42, and then add the whole numbers, and I get 3. 37 and 42 do not have a common factor other than 1, so therefore that answer is in simplest form. Now, taking a look at subtracting mixed numbers. There are two approaches that you can use here. It just depends on which one is easier for you to understand. I personally prefer regrouping, which will be the first method I show you. The second method that I show you will be using improper fractions. So, let's go ahead and take a look at this problem. We have 3 1/4 minus 1 1/3. So I'm going to set this problem up vertically. And our first problem, we dealt with 3 and 4, so I'm not going to go through the steps of listing the common multiples. We're just going to go ahead and establish the fact that the LCM of 3 and 4 is 12. So I'm just going to rewrite these mixed numbers here so that the denominators are 12. Now, think about how I go from 4 to 12, and that's by multiplying by 3. So what I do to the 4, which is in the denominator, I must also do to the 1, which is our numerator. So 1 times 3 equals 3. Looking at 1 1/3, making it into 12s, we multiply the 3 times 4. So you also have to multiply the 1 times 4, and we end up with 4. Now here's where we run into an issue. You'll notice that if you subtract 4 from 3, you get a negative number. And we want to avoid that. So what we're going to do is regroup. Regrouping mixed numbers is similar in a sense to regrouping whole numbers. So what I'm going to do is cross out this 3. Now I'm not getting rid of one whole. I'm just going to take that one whole and I'm going to write it as a fraction. So the 3 then becomes 2 and 12/12. Now you may wonder why I decided on 12/12. Well, if we look at our denominator, we already have 12s. And I know when I add fractions, I need a common denominator, so it's best to just keep that 12 in there so it doesn't require any extra work. And remember that a whole number as a fraction is a number where the numerator, 1 as a fraction could be represented by any number over itself. So in this case, 12/12 represents 1. So I can't forget about this 3/12, so what I'm going to do is just add it to the 12/12, and I end up with 2 and 15/12. And I'm just going to draw this arrow showing that I'm moving the 1 and 4/12 right on over so that I can then subtract. So 15 minus 4 equals 11/12. 15/12 minus 4/12 equals 11/12. And then 2 minus 1 equals 1. So my answer for this particular problem is 1 and 11/12. Now, I'm going to solve this same problem, 3 and 1/4 minus 1 and 1/3, using mixed numbers. Set the problem up vertically, so I have a place to write those equivalent fractions, or in this case, mixed numbers. And I just wrote the adding sign there, so let me erase that quickly so we can move forward. Alright, so we're subtracting. So in the last problem, in our last example, we worked out, or we just established the fact that 12 is going to be our common denominator. So I'm just going to go ahead and find the common denominator before I turn these into mixed numbers. Make my life a little bit easier, I think. So 4 times 3 is 12, so 1 times 3 is 3. And then down here at the bottom, 3 times 4 is 12, so 1 times 4 gives me 4. Now I end up with that issue of not being able to subtract 4 from 3 without getting a negative number. So what I'm going to do in this example is take this 3 and 3/12 and 1 and 4/12 and make it an improper fraction. In order to make a mixed number an improper fraction, you multiply the whole number times the denominator and then add the numerator. So 3 times 12 equals 36, plus 3 is 39/12. And then over here, down here, we have 1 times 12, which is 12, plus 4, which is 16. So I end up with 39/12 minus 16/12. When I complete that subtraction, I'm going to end up with 23/12. Now, you're more than likely will need to turn this improper fraction into a mixed number. Sometimes you may not have to, but I'm just going to go ahead and show you an example of what you would do in this case. So we're going to again divide the numerator by the denominator like we did in an early example. So again, we're going to divide the numerator by the denominator like we did in the early example. So 12 goes into 23 once, and then I'm going to subtract 12 from 23, and I end up with 11. So I get 1, remainder 11. Remember that quotient, which is 1, is your whole number. The remainder is your numerator, and your divisor is your denominator. So you'll notice in both of these examples, when I use regrouping and when I use mixed numbers, I ended up with the same final answer, which is 1 and 11/12.